Hey guys, it's Horner, and I just want to go through this as projectile motion question F1, and I want to go through it, just kind of show you how to do this one. So most smartphones, if you have a smartphone like an iPhone, have an accelerometer on the inside, and what's cool about those smartphones is they will actually measure acceleration in the X, the Y, and the Z axis, or left, right, up, down, and in and out. So if you put your cell phone on the dash of your car, or just on the seat next to you, and you start recording, what will happen is you'll be able to, if you use the right app, you can see what happens as you're driving around. So I'll have to show you that when we're back taking a look at it again. So anyway, for some reason there's a physicist who attaches it to the bottom of the car. Don't know why. You could really just place it anywhere in the car, but nonetheless. If you look at this, you'll see that the acceleration versus time is plotted, and it's both in the X direction and in the Y direction, which is really super important for this problem. If you plot it in the X direction, you'll notice this is positive X and negative X. If it's turning left, it will accelerate to that negative direction, because remember, that is the centripetal acceleration. That is the centripetal acceleration, and so that would point towards the center. If they turn right, it'll go this way, and then the acceleration would be to the positive X. So here we know that this person has got to be turning right, and here we know that this person's got to be turning left. So that's the first thing to see. In the Y direction, positive Y would be meaning that you're going forward, and here this would be going backwards or going in reverse. Or your acceleration would be in the reverse, which means that if you're traveling forward, and that's your velocity, and your acceleration is in the backwards motion, then you are slowing down. And that's what's happening in this case. First thing they want us to do is calculate the speed of the car at 7 seconds. So to do that, we're only going to look at the acceleration in the Y direction. We're not going to look at it in the X, because that's what happens when we turn. And the Y direction is going to increase and decrease our overall speed. So for this one, we see at 7 seconds there isn't any, but up to 7 seconds we can go up to 2 seconds. It is accelerating. Because it's accelerating, we're going to find the area of that acceleration versus time graph. And when we do that, we just take 3 meters per second squared. We multiply that times the 2 seconds that it's accelerating. We see that we're traveling now at a constant velocity of 6 meters per second. So when the car turns left and right, its speed is 6 meters per second, but its velocity changes because of change in direction. So just a lot of stuff. All you need to do for this one, though, is do this part right here. The next thing they want us to do is find the radius of curvature of the car's circular motion at 7 seconds. So you'll see that at 7 seconds, it is turning right. And if it's turning right, we know that that makes a circle. And we can find the radius of curvature. So that would be R at that 7 second period. Acceleration, centripetal acceleration is equal to v squared over r, so here we can say that r is equal to v squared over a. We know our speed is 6 meters per second, and we know that acceleration is 3. How do we know that it's 3? Because when we go to this graph, you'll see that in the turning direction, the acceleration is 3 meters per second squared. So we're going to have 6 squared over 3, that's 36 over 3, so the radius here is 12 meters. Next thing they need for you to do is talk about, in words, how the driver operates the car during this 10-second interval. Discuss the use of the accelerator pedal, the brake pedal, and the steering wheel. So here the driver really is just pressing on the accelerator pedal for 2 seconds. So if we go back up to the graph, you can see it. For 2 seconds, pressing on the accelerator pedal. Then they let go of the accelerator pedal, and they start to turn left. So they turn the wheel to the left. And then they immediately turn the wheel to the right at 5 seconds, and they do that for 3 seconds. So 3 second turn to the left, 3 second turn to the right. If you go 3 seconds left, and then you do the same thing right, notice that you're going to be going in the same direction that you originally started, and that's covered in the next part. Then, for the last 2 seconds, you'll see that this person presses on the brake, and we know that they press on the brake because we see that the acceleration is in the negative direction, just like we said here, as they're going forward, so they are slowing down to a stop. For part C, they want us to go through and try to figure out where this person is going to park, and they park at point B. And they want us to draw the car's path between 2 and 10 seconds. So they've already drawn 2, they've already drawn the 10-second mark, they just don't put it. And on the path we have to label 5 and 8 seconds. So for 3 seconds, this is 3 seconds change in time. We are turning left, and then there is another change in time here equal to 3 seconds, so 5 to 8, and that is turning right. So now that we've done that, we are set and done with this problem. That is 7 points.